Hello, grade 11s. In this video, we are going to look at Introduction to Organic Chemistry, the first topic in grade 12. In grade 11, we learned about the Lewis structure, and we learned that whenever we have a compound like this, that is a methane gas, to do the Lewis structure of this, we therefore have to take the C as our central atom because it can form the highest number of bonds. And then to do the Lewis structure of it, that is how it's going to look like. And then the H's or the hydrogen now comes to H. Bond to it. Okay. And also we can also write this as So now in grade 12, we're only going to concentrate on this way. All right. And whenever we have carbon, hydrogen bonds, we call this compounds organic compounds. So in grade 12, we are only going to talk about organic compounds. Okay, and to do the structure, to write the structure formula of a compound, organic compound, we call it structural formula. To write the structure, okay, we call it structural formula. For instance, if I have, say, CH3, CH2, and CH3, to write the structural formula of these compounds, I have to therefore write my C. I know the C's to be the central atoms because they form the maximum number of bonds. So the first C here has 3 hydrogens surrounding it. Now, on its right, it is bonded to another C. That's why I didn't put the hydrogen starting from that side. So I have to write the second C bonded to 2 hydrogen. On its right side, it's bonded to another C, so I'm not gonna put any H on the right side. Now, on the right side, it's bonded to another C, which is bonded to 3 hydrogen. So now, that is how to write the structural formula of this one here. Now, the next one is, I'm going to draw the structural formula of this. All right. Now, the first C has 3, oh, let me just make it 3 here. The first C has 3 surrounding it. The second C has only 1 surrounding it. And the third C has 2 surrounding it. So I can put it on top or at the bottom. It doesn't matter where you put it. You can put it on top or the bottom. It's okay. Now, I'm done with this, but I know that the C can form the maximum of 4 bonds. So if I have to look at the first C here, it is okay because it has 1, 2, 3, 4 bonds. But if I have to look at the next C, it has 1, 2, 3 bonds. And the last C also has 3 bonds. So I therefore have to put a bond somewhere in such a way that the 2 C's are going to have 4 bonds. So if I put the bonds here at the last part here, it's not gonna work in the sense that this is going to be okay, But what about this one here is not going to be okay. So therefore, I have to put the C here. If I put it here, now I am going to have this to have 4 bonds because I have 2 here. The 2 goes for the 2. This one and that one. So I have 4 here, 4 here. So that makes it perfectly. So now this got its structural formula to be this one. Now the next example is I have C3 and I have C and I have C1. Now I have to draw the structure for this. So the first C has 3 surrounding it. The second does not have anything surrounding it, any H. Sorry. And the last has 1, 2, 3. The last has only 1 surrounding it. So let me see. We have 1, 2, 3 C's. So if that is the case, now I have to put some bond somewhere so that my C's will be okay. I can see my H's are okay. But this and that, they are not okay. If I have to put any bond here, it's not going to work because this is okay. Now, if I have to put it here, it's not going to work because it is okay. So this is my only option, this side. So if I put 1 here, double bond, then I ask myself, is this C, does it have 4 bond now? Does this have 4 bond now? No, it has 3. This has also 3. So if I put another bond, then I know that, oh, putting another bond, it makes all of it okay. Now, this one here has 4, this one has 4. So the structural formula of this is that. Now, let's move on to another example. I have CH3 and I have CH and then Br and then I have CH3. Now my first C has 3 bonds, 3 H's surrounding it, which is bonded to the right to another C. And that C has 1 H, 1 hydrogen, and 1 bromine. All right. And bond to the right, it is bonded to another C, which is bonded to 3H. So that is my structural formula. The structural formula of this is that. All right. Now, let's move on to the next example. All right. The next example, CH3 and then OH. So for the OH, whenever we see OH bonds, O can form 2 bonds, H can form 1 bond. So this is what we have to do. That is how to do the structure for OH bonds. Now, if we have, let's say, if it is COOH, then the first C is bonded to 1 O and also OH. So if it is bonded to O, it is a double bond. And OH, that is it. That's what you have to always remember. All right. So now let's move on to our now to do the Lewis structure of this, we have our first C. 1, 2, 3. And on the right, it is bonded to OH. So that is the structural formula of this is that. All right. The next example. If I have C3 and then I have CO and then I have CH3. Now, the first C is bonded to 3H, so I am doing it. On the right, it's bonded to C, but that C is bonded to O. And whenever it's bonded to only one O, it is a double bond because O doesn't form a single bond. It only forms a single bond when it is with hydrogen. Okay, so now on the right, we have another C, which has 3 hydrogen surrounding it. So the structural formula of this is that. Now, the next one, which is CH3OO. If you remember this when we were doing acid and base, that is ethanoic acid. Now, the first C has 3 surrounding it, and it's bonded to H on the right, sorry, C on the right. And that has O, which is double bond, and it is bonded to the hydroxide. So that is the structural formula of this one, which is ethanoic acid. All right. Now, if we have our last example for the day, then exercise follows. If we have CH3OOCH. Now, the CH, C has 3 surrounding it. And then on the right, it is bonded to. So now, whenever you have random oxygen in the middle, right, you can see this one here is bonded to the side. And then it is also bonded. Now, the O, which is next to the C, the O, which is next to the C, is always a double bond. But the O, which is next to the H, next to the C with the H, like this, is the single bond. So here we shall have single bond, and it will also be bonded to this side, which is the C. And now this shall have the double bond. And then this is also bonded to this H. So we call this random oxygen in the middle. So whenever you have random oxygen in the middle, just look at this O. Now here, this O here is closer to the C. You see, so this would be the double bond on this, and this would be the oxygen in the middle. So now that is it. So now the exercise follows. You're going to draw the structural formula of the following. So you're going to draw the structural formula of the following. All right. One. 2. 3. CH. 3 CH. 2 CO. CH3. And then 4 CH3. CH. CH. NOH. And CH3. Okay, so on this C has this and has also hydroxide bond to it. All right, so the next, which is 5. Oh, 5. Question number 5 has CH3, CH2, CH2, okay, CH2, CO, CH3, 6, CH3, CH2, COOH. The next one, CH3, CH2, OO, CC, H3. All right, so this is what you have to try your best on it. So I will appreciate if you can do this and get back to me. Okay, if there is any comment, you're welcome to comment. Until then, goodbye.